Welcome to MRU E-Learning powered by Mallarity University. I am Dr. N. Chandar, Associate Professor, Department of Cybersecurity, Mallarity University. My topic is today Generative AI, the AI revolutions. So how the AI is transforming in the present era, we know that. So the outline of my presentation, here is the introduction to artificial intelligence, introduction to generative AI, and what are LLMs models, and prompt engineering. So coming to what is the artificial intelligence. So artificial intelligence here is simulating the human intelligence processed by machines, and a broad field of computer science focus on the creating the systems that can simulate the human intelligence to perform the task. This includes the learning problem, solving the perceptions, and decision making to decide the main decision or to take the proper to generate the proper data. So we can use the artificial intelligence, and the code is AI aim to create the machine that can think and learn and act like a human. So here generative AI and this artificial intelligence, the mainly use the human intelligence, not using the human brain. So like act as a human intelligence. And coming to here, the artificial intelligence. So artificial intelligence here is the entire world. You can see that artificial intelligence. So here the subset of artificial intelligence is machine learning, deep learning, and subset is generative AI. So here you can see artificial intelligence. So here in artificial intelligence, any techniques that enable the computer to mimic the human behavior, right? And coming to machine learning, this is a subset of AI, and the subset of AI enable the computers to learn the pattern from the data. So it to train the machines. And deep learning, so deep learning here is the subset of the machine learning, and more like human brain. So and coming to next is generative AI. So generative AI is a major role in the present era. So creating the new content and visual and auditory content based on the prompt. And the evolution of AI. So here you can say the rule-based system. The rule-based system here is 1950 to 1970. The AI was driven by the expert system. So human explicitly programmed all the rules and logic. So in this era, AI is only follow the what are the rules are given, and the rules need to follow. Coming to machine learning, so here 1980s to 2000, the machine learning began to learn from the data. So machine learning started to learn the data from the data. The algorithm could identify the patterns and prediction without explicitly programming. And here deep learning. So deep learning in from the 2010, a subset of machine learning is using the neural network with many layers and enable the breakthrough in image and such speech recognition. This purpose we are using the deep learning. And coming to the present, the 2020 to present, so everyone using the generative AI. And so we know that modern tools we are using. So that tools are we will discuss. So model can be now create a new and original content from the text or image or code also. And here you can see generative AI. So generative AI is generating the content and text, image, audio, video, code. This related, and AI is using the intelligence. AI here using the human intelligence. And coming to here, you can see the major difference between generative AI and traditional AI. In generative AI, with purpose mainly we are using here is to create the new data. To creating the new data, the data related the text to image or music. So this type of data we can create using the generative AI and data driven learning. That is a neural network concept, and is entirely the new content. The generative AI is a new content, and innovative creating the new dishes, and creativity content generating the exploring the possibilities. So this comes under the generative AI. And coming to traditional AI, the traditional AI is we need to analyze the data. Whatever the data is there, the data we need to work on that. We need to analyze the data and we need to perform the specific task. So explicitly rules and algorithm. We need to follow the some explicitly rules and algorithm and solutions and classification. We need to classify that particular whatever the data we have. We need to analyze and classify that. And master chef following the recipe, right? And here we need to follow the what is accuracy, efficiency, and reasoning. So when we are giving the content to the generative models, LLM models, so text or image we can give. The text is a text or image. So the text or image we are generating the models with the generative models. So LLM is large language model and LIM large image model. So this models gives to the ChatGPT, Google Bard, Stable Diffusion or DALL-E. So and finally it provide the output. So output is related again based on our text or image or audio video. So what are LLMs? So LLMs is an ecosystem for generating the models and language model. So here you can see language models. What are the language models? So how we are giving the prompt, that is very important. Coming to here, man sat on the. So this is given the prompt as this is our input, right? And it's give to the next thing. What is the token? So I mean, what is the probability of the next token be generated? So that's handle the language model. So here the probability of the output is based on that. Whatever the probability of the given next token is based on that, it provide the output. And the large language models here is a specialized type of artificial intelligence that has been trained on the vast amount of the text to understand the existing content and the generative original content. The model can be produce a text, audio, video data. So here the characteristics of LLM. So this LLM is a large number of parameters. This LLM train on the millions of parameters and train on vast data set. So number of data set it train on that and versatile and general purpose. So the benefits of this LLM is perform the diverse tasks and adaptable through fine tuning. So for it specific whatever the model we are using, either fine tune that particular data and improve the continuously with more data. So these are the major, right? And how our LLMs are created. So this LLM is created is, you can see this is a one flow. So first we need to pre-train the model. So based on the whatever the data we have, so we need to select the proper data. Then we need to train. Hey, this data is taken the website related data. So URL filtering. So first when we are URL filtering here, we need to remove the low quality or unsafe the websites. And text extraction, whatever the data we are taking from the website, we need to extract the data. And language filtering. So here language filtering, we need to select the required language and go for filtering. So here is a specific data set we need to select in this stage, and has duplication. So we need to duplicate the data and we are using the C4 filters. So here we are using for large amount of data for this like C4 filtering and customs filters. So we need to customs to remove the noisy this purpose or any unwanted data we remove from the customs filters, and we can remove the whatever the unwanted information from the PII removal. So these are the stages: the base model training and post training and reinforcement learning. So the base model training here is a training on vast data set to learn the patterns on grammar and reasoning. And techniques used for this base model training is, so we can use a self-learning, self-supervised learning, transformers, large scale data set training. And coming to the post training here is, so improve the accuracy, safety purpose and domain relevance, we can do this. So here is we are using the supervised fine tuning and instruction tuning, domain specific adoptions. And reinforcement learning here is for optimize the response based on the human feedback for better alignment. So reinforcement learning for human feedback. This purpose you can use it here. So actually here you can see how the prompt is working, how the token is generated based on the prompt. So here you can see one statement, what a beautiful day the sun is. So here which token is the next? Right here which token is next? So based on the probability, LLM will take handle this. So here you can see, for example, we need to provide the one prompt in this token. So here the probability we need to check. So what a beautiful day the sun is shining. What a beautiful day the sun is rising, and what a beautiful day the sun is out. So these are the major probability to take the next token. So instead of that, if you are taking low probability, so sun is exploding. So this is a very low chance to take the token. So how to select this? So we are selecting here is based on the neural network concept. So the neural network concept here is a complex mathematical model language and store which words frequently appear together in which order, contextual meaning. So which word is coming to the next based on the probability, and LLM use the model to generate the text, what text is coming the next. So the LLM. So here you can see the probability here, what a beautiful day the sun is. The process of identifying the probability of this next token, the LLM model will decide. So based on this, so here you can see snoring is 0.001 and exploding 0.0. So this is a less probability to select the next token. So here you can say the shining is the highest probability. So it's come here is a shining. And LLM use case tasks. So LLM you how to use this is based on that you can see essay writing purpose and summarization given the content and translations. Translation purpose also we can use. On information retrieval system, we need to retrieve from the data. We are using information retrieval system and invoke the APIs and action to follow some. We need to invoke the APIs and perform some actions on that. So we have to follow, and external application will be work on this. So the recipe for large language model. So here we are using the massive data. So this massive data is the train on the from the whatever the books or from Wikipedia to be significant portion of the entire internet. So this whatever the millions of parameter, whatever the data set we are taking. So we'll work on that and new algorithm. So the transformer architecture was highly parallelized and efficient, allowing the model to scale to billions of parameters. So it train on the whatever the data we are taking based on the data set. So these parameters will be considered, and powerful hardware to organize this. So we need the powerful GPUs, TPUs to handle this type of LLM models. So these are the some generative AI tools. So ChatGPT. So this good conversation capabilities purpose we are using. CLAD, so smart and insightful answers. So Gemini, so large content and effective response. So Gamma here for making the presentation purpose we are using. Grok for research based reasoning questions purpose, and DeepSeek. So for research and base reasoning questions. Perplexity. So source citation purpose or real time web search purpose you can use. And notebook LLM. This is excellent for whatever the more precise for whatever the data or PDF we have. If you need some precise notes or whatever the content of we are uploaded, whatever the data mean PDF or whatever the files. And next one is a prompt engineering and semantic search. So this is mastering AI interactions and information retrieval. So the prompt engineering is very, very important or a major role in this. So why prompt engineering is matters. So here you can see prompt engineering is a practice of designing. Why we are using this prompt engineering? So the difference between the prompt and prompt engineering. So we will discuss. So here prompt is when we ask one time, our ChatGPT or any GPT models what we are using. So the first time, without we are asking any given instruction to follow that, just we are asking the question, given the instruction and we are getting the answer. So one time we are giving, that is the just what we are giving the English, right? And same way, prompt engineering is we are specifying the so and so problem to give the proper inputs or insight output for that given problem. So here the prompt engineering is the practice of designing and crafting, optimizing the prompts, the input or instructions given to an AI model produce a specific, accurate or useful outputs. So here providing the quality of outputs and reliability and accuracy. These are the major in this prompt engineering. So here the major of this prompt, art and science of the talking to AI. So need to talk AI how to get the proper input from the data, right? And what are the prompt? So prompt is nothing but here involving the instructions. So here prompt is involving the instructions and context passed to a language model to achieve a desired task, right? And next prompt engineering is a practice of developing and optimizing the prompt to efficiently use the language models LLM for a variety of applications. So here you can see, here we are given the one prompt. So what is a prompt engineering? So this is the just one prompt we are given. So it provide the what is the prompt engineering, right? So the major here is, so when we are giving the prompt, so just for our example, what is API? So this is the without giving any instructions. When we are not asking any precise output. So just API. So here give the API is so and so is a broad area of a domain, and like that the answer is provided. When we are using the prompt engineering to this API, so we need to provide, so giving the instructions, explain API. So this is the instructions, right? And API. So we are giving the one input, and here we are asking to some past API, right? Some fast API. So these are we are giving the some content. Same way here you can see in the first basic block here we are giving the instruction the sky is. So here this is the one prompt we are giving. So the sky is here token is generated and it give the response. Same way. So in prompt engineering we need to give the some instructions and we need to give the some context and we provide the some input, and same way it is some output also we need to expect. So what type of input is we required? We need to give the proper prompt. So that is the prompt engineering. So we need to specific input we have to give. Example of prompt here. So you can see we need to give the some instructions, the data, input data, and whatever the content is required, and input indicator. Based on that, we can get the proper output. So in prompt engineering also we need to follow the techniques. Prompt engineering also we need to follow the techniques. The techniques is so zero shot or few shot techniques and chain of thought, adding the content, persona, specific format or examples, and iterating to guide the model. So we need to guide the model. So we need to follow these techniques like ChatGPT or image generators. So here you can see zero shot prompting. So in these techniques, so definition is asking the model to perform a task without providing any example or context. So we are not providing any example or we are not asking the specific output. So here, just we are writing the one prompt and we need to get the output. So coming to the what are the good prompt or bad prompt, how to fail this, you can see the zero shot when it is works, when it fail. So here you can see for faculty perspective, here is a comma simple task. So here, for example, we need to drop an email to any persons. So here we need to this is a good and general knowledge questions. So we need to asking any general knowledge question. So the zero shot related techniques is good. It work. And creative brainstorming. So give me three analogies for quantum physics, like that questions. So it work very well. The zero shot prompt. So when it fails, the complex or multi-step logic, if you are asking. So we need to precise, we need to give the proper prompt. So in zero shot is fail. And so this is the example how it is work. And few short prompting. So here we need to give the we need to provide the examples, or we need to give some response to a model. So definition is providing the model with a few example to guide the response. So example here you can see one prompt we are given here some example for Python function that calculate the square of a number. So we are given. So it provide the proper what square of calculating that. And next one is, so if you need the cube of a number, so again we need to give the precise input. And the prompt you can see have the feedback related. They classify the student feedback as a positive or neutral or consecutive. So student here given the one statement here is the professor was great and I loved the class. So the output is a positive. So student again the course, this course is a requirement for my major. So this is a neutral. And another query prompt here is the lecture were clear but the textbook was confusing. So this is the consecutive. Same way another is I enjoyed the guest speakers but the homework felt like busy work. So what is that? So we need to think and answer. This is the consecutive model, right? Next one is the chain of thoughts. So this chain of thoughts prompting here. So in we can see in our schooling age. So in class they are giving the one problem, right? So that problem we need to solve. So already we solve on based on the different approaches. So not only so what approaches we are applying the different formulas, but whatever the solution is the same, right? So the same way the chain of thoughts also, the encouraging the model to explain its reasoning step by step to improve the complex problem solving. So how in our schooling age, whatever the problem we solved, same way when we solve the different way, our teacher tell that, so this is the not proper way to follow this. So you need to follow this procedure. Same way here in the prompt chain of thoughts also. So solve the following math problem step by step. So this is the statement is given and expected model output is given this, right? Thank you.